Hi everyone, I'm Naminan, a graduate student in the XFAC lab at KaiSei. I'll talk about a recent work that will be published in Findings of EACL 2024. Sentence embeddings with contextual representations are more informative than static text embeddings for various natural language processing tasks. There are 4 sentence embedding models: unsupervised, LLM supervised, human supervised, and human plus LLM supervised. As you can see from this figure, we observe that LLM-supervised models often underperform models trained on human annotated data. This observation leads us to investigate 2 research questions. First, what properties exist in LLM-generated positives, negatives that differ from human-generated texts for building sentence embedding models? Second, are the standard contrastive training objective losses, such as SIMCSC and CLHAIF, sufficient to learn the relationship between sentence triplets? So, how can we discuss each research question as shown in the previous slide? First, we conduct a heuristic evaluation on human LLM-generated datasets in terms of these 4 perspectives. First, positive text repetition, PTR, measures the overlapping 1 gram between reference and positive, excluding the subject. Second, positive score compactness, PSC score, is a reciprocal of the variance of similarity scores between reference and positive. Third, length difference penalty, LDP score, is penalized if there is a large difference between the length of reference and positive. Lastly, negative text implausibility, NTI, scores the implausibility of hard negatives by prompting GPT 3.5 to answer in a binary mode. Then we also propose what we call a PNA loss. This loss is constructed based on the observation that the pulling reference positive pair together and pushing the reference negative pair apart does not always guarantee the ideal far distance between the positive and negative. Note that this loss can be applied to any sentence embedding model fine-tuned with either human-generated, LLM-generated, and human plus LLM-generated sentence triplet datasets. Our first result shows that the human-generated NLI dataset scores the lowest PTR, PSC, LDP, and NTI scores, showing inherent irreducible differences between LLM and human-generated texts. We also showed that fine-tuning with PNA significantly improves Spearman correlation, as well as it mitigates sentence anisotropy compared to static token embeddings and embeddings from pre-trained only models. The most important result would be that pushing positive and negatives apart in the fine-tuning process allows the sentence embedding model to capture more varying levels of similarity scores between sentence triplets: reference positive and reference negative, positive and negative. In comparison to baseline, which does not incorporate the relationship between positive and negative, and the false negative elimination method, which eliminates 1 false negative per sample within a batch, we find that the proposed PNA loss enables model to achieve enhanced correlation with human evaluation and lower sentence anisotropy. So, what is the motivation for proposing PNA loss after the heuristic evaluation? After finding the inherent difference between LLM and human-generated datasets, we attempt to devise a way to improve any sentence embedding model that uses sentence triplets as a fine-tuning datasets, no matter whether they are trained with LLM only, human only, or human plus LLM generated datasets. Why is it important to consider the relationship between sentence triplets? Well, there are subtle differences between similarity scores, even for the sentence pairs labeled as positive pairs, so which implementing the PNA loss helps to achieve better. For instance, this first pair of sentence, which is I love to explore NLP and I like to explore NLP, scores a similarity score of 0.9, which is more than the next positive pair, which is I love to explore NLP and AI, and I love to explore Arch, which scores a similarity score of 0.7. This is the end of the presentation. If you have any questions, further questions, please don't hesitate to contact us through this email. Thank you.